ColBERT model is actually a bioencoder, but it has the interaction late. So it's like a late interaction model where you have token level interactions. And many believe that these token level interactions, even if they're late, they're doing at the scoring time, gives that type of model a better, it generalizes better to new domain or new text. Because let's face it, what you actually typed does matter, right? If you typed Coke, you might want to match a document that has Coke. You might not want to match Pepsi if it has the same similar semantic meaning.
Can you maybe quickly define like the difference between early and late interactions?
Late interaction was introduced by the ColBERT paper by Omar in the sense that the query and document tokens are not interacting when we are encoding them with the transformer model, right? That enables us to encode the document corpus upfront, offline. So we can encode the document collection, and at query time, which is the late time, we can have that type of interaction using this multiple vector representation. So that's where the late part comes in. But in a more like an early sense would be more like a cross encoder where you're interacting throughout the transformer model with the same inference call, and each of the tokens will interact. Same with when I talk about cross encoders, this also applies to using regular LLMs like Rank GPT or things like that, where you're actually using more of a generative model where you basically stuff the prompt with all the documents and ask the model to rank them. There you also have interaction throughout the decoder network between all the tokens. But ColBERT enables us to have this kind of interaction with the tokens with neural representations or vector representations.
Yeah. And now moving on to the actual topic of the episode, we discussed ColPali. How does the late interaction model was introduced to like the visual domain in ColPali?
Yeah, so ColPali takes the late interaction scoring mechanisms from the ColBERT paper or the ColBERT approach and brings that to and combines that with a visual large language model or a visual language model, Polygamma from Google. So it uses Polygamma to obtain a multi-vector representation of a screenshot where you essentially take a screenshot of a page, for example, a PDF page, and that page is divided into grid cells. And each of these grid cells are represented as a vector. Like in the text domain with ColBERT, you will represent each of the text tokens in the text as a vector. And they are mapped into the same vector space where you're also matching text tokens because it's vision language models. It's combining a vision encoder with language models. So they have learned joint representations of both text and image data. And similar as ColBERT, you do the same thing with the query, which is text only, or it could also be an image, but in the ColPali paper, they only touch on you having a text query and you have the document you want to search in. And then you do the late interaction or the maxim scoring, which essentially computes a matrix multiplication.